Assalamualaikum and hi, my name is Abdul Yafiq Azwan bin Abdul Rahman. Today our group will be presenting about moment. A force moment is a measurement of its ability to induce a body to revolve around a given point or axis. This is distinct from a body's inclination to move or translate in the force direction. The power must act in such a way that the body begins to twist in order for a moment to develop. This happens whenever a force is applied that does not travel through the body's centroid. A moment occurs when a force does not have an equal and opposite force acting in the same direction. Consider two persons on opposite sides of a door pushing on the doorknob. There is a state of equilibrium when both of them are pressing with equal force. If one of them suddenly jumped back from the door, the other's push would no longer be met with resistance, and the door would swing open. A pause was made by the individual who was still pounding on the door. Moments are used in a variety of daily tasks. As we all know, a spanner, for example, is used to open and tighten nuts on various places of the bike where nuts are present. As indicated in the diagram above, the application's moment is just a plain moment in this case. The turning effect of a force is defined as the moment for the application of the spanner. Moments are caused by forces acting around a pivot point. The pivot of the object's pivot, which allows it to rotate and turn. The pivot point of a seesaw is the center of point. It allows measuring the perpendicular distance between the force lines of action and the pivot easy. When you spin a spanner such that the pivot is at the bolt, however you apply force to it, there is a distinction between the two images based on the schematics A and B. The spanner in diagram A is longer than in diagram B. To clarify, the length of the spanner has an effect on the amount of moment produced, because the force required to move the spanner differs. This is said to be the case. The moment for using a long spanner is smaller than the moment for using a short spanner. According to the assumption, because a longer spanner uses less force than a shorter spanner, it is more efficient. Assumptions about the sum of these moments can be defined by the following calculations, which is m equal to F multiplied by D. M represents moment which measured in Newton meter. F is force which measured in Newton, while D is the perpendicular distance from the pivot, which is measured in meter. That's all from me. Thank you.
Hello, my name is Basir Badnan, and now I will talk about basic theory of moment. That is, element of a moment. Okay, my first point for moment topics is the magnitude of the force operating around a point, or at least has a direct relationship to its distance from the point. It is the sum of the force and the moment arm. The perpendicular distance between the line of action of the force and the center of the moment is referred to as the moment arm or the lever arm. The location right around the force driving the rotation is called the center of the second. It may also be the reference point around which the force is considered to rotate. It makes no difference as long as a particular point is used as a reference point at all times. In structural design difficulties, the latter type is much more common. Then, the unit we use for moment is feet-pound, keep-foot, Newton meter or kilonewton meter. For positive moment is a moment that rotates clockwise around the center of the moment, while the negative moment is a moment that rotates counterclockwise around the center. When a pure moment is applied to an item, it may be transported to another location without affecting its behavior because the response is the same. This means that the number of moments can be calculated in any part of body and the result will always be the same. This is very useful because it allows us to calculate the number of minutes from any point. So that is my presentation. I will pass it to Hazrul.
Assalamualaikum warahmatullahi wabarakatuh. Another example of application of moment is seesaw and a wrench. A seesaw and a wrench spinning a lug nut. If a pivot point on the seesaw, there is a balancing point, and the lug nut is safe in the wrench and lug nut combo. All of the forces are concentrated in this location. There is a point of application of force in each circumstance. It's the seats on the seesaw that hold the children, each of whom is varying weight. Weight is really a type of force in the physics domain. In addition, are some of the examples for the couple of moments in our daily life. Opening and closing of a water tap, bending the spring of an alarm clock, opening and closing of a cap of a water bottle, and lastly, turning of a screwdriver. That is all from me. Thank you.
Hello, and my name is Safambe Ismail, and I will be explaining about the analysis and calculation. To open a nut in diagram A in 2.0 background of case study, a person pushes on the edge of the spanner with a force of 13 Newton. The distance between the hand and the pivot is 20 centimeters. What is the moment used to open the nut? From the information given, we got the force, which is 13 Newton, distance, which is 20 centimeter, but we convert it into meter, and the question asks to calculate moment. From the formula m equals to force times distance, we can replace the value from the information given into the formula. So we got m equals to 13 times 20 over 100. We calculate it and we got m equals to 2.6 Newton meter. Next, to open a nut in diagram B in 2.0 background of case study, a person pushes on the edge of the spanner with a force of 21 Newton. The distance between the hand and the pivot is 14 centimeters. What is the moment used to open the nut for the spanner? From the information given, we got the force, which is 21 Newton, distance, which is 14 centimeter, but we convert it into meter, and the question asks to calculate the moment. From the formula m equals to force times distance, we can replace the value from the information given into the formula. So we got m equals to 21 times 14 over 100. We calculate and we got m equals to 2.94 Newton meter. From question A and B, is that true that the moment for using long spanner is smaller than by using a short spanner as assumed in the background of case study? The answer is yes, it is true. Moment for using long spanner as shown in question above is equal to 2.6 Newton meter, which is smaller than the moment of using short spanner. It is because the force needed to push the edge of the short spanner is bigger than the force needed to push the long spanner. Next, I will be explaining about the discussion. According to the results of our experiment, the length of the spanners produce a varying amount of moment, because the force necessary to move a spanner varies. This is the case. Using a long spanner creates a smaller moment than using a short spanner, according to the assumption, because a longer spanner takes less force than a shorter spanner. This is the case. To assume the more force necessary, the shorter the perpendicular distance from the pivot, which is the spanner's length. Furthermore, the moment formula is m equals to F times d. where m represents the moment in Newton meters, f represents the force in Newton, and d is the perpendicular distance from the pivot in meters. Moments or turning effect are also utilized in a range of applications, including the opening and closing of a water faucet, the opening and closing of water bottle lid, and screwdriver turning. Finally, levers employ moments to act as a force multiplier. They exert a higher force on the weight than the effort does, making it easier to move a large or heavy objects. The longer the lever and the further the effort works from the pivot, the greater the force on the load. That is all from me. Thank you.
In conclusion, this concept is important in structural engineering as it can be used to calculate where and how much bending may occur when forces are applied. For conclusion, learning about a moment of force has shown that many benefits can be obtained from this topic either in terms of systematic or practical learning. In the meantime, the topic of moment of a force is often used in daily life without realizing it even without a specific lesson. However, the lesson is also important to facilitate daily affairs, especially for students who major in mechanics that later as a mechanic will make extensive use of this method in every job done. So we hope that the exposure to the topic of moment of force can be strengthened our knowledge of on how to apply it in life, and we hope it improves our performance as a mechanic one day. That is all from me. Thank you.